My goal today is to update you on the work that was done by SWAT team G305 Solar Energetic Particles in Geospace. The main focus of the team is understanding and numerical modeling of such a complex phenomenon as the energetic particle population in geospace and how that is affected by perturbation of the geomagnetic field during active time. Uh, the ionizing particle radiation started from the commercial aviation altitude in the troposphere to the space outside of the magnetosphere is filled up with energetic particles. Those are harmful not only to humans but also to spacecraft. We cannot turn off the radiation, but what we can do is to try to understand how it behaves to minimize the harm. Uh, Building an integrated model to characterize solar energetic particles in geospace is a primary focus of the ISWAT Team G305. Methodologically, this goal is achieved by combining outputs of existing models into a global solar energetic particles simulation. Particularly, the boundary conditions for the modeling of solar energetic particles in geospace are derived based on the flux and energy spectrum calculated by models IPAS and M-FLAMP outside of the magnetosphere. The geomagnetic field is calculated with SWMF Betsaras, and the transport of energetic particles in geospace is simulated with another component of SWMF with kinetic code EMS. We also intend to validate our modeling approach by comparing the results with in situ observation of September 17th solar energetic particle event. Being ions, solar energetic particles are affected by geomagnetic field. Depending on the energy, these particles respond to the variation of the geomagnetic field to a larger or smaller degree. Effectively, geomagnetic field serves a filter that prevents some of these particles to enter in the inner part of the magnetosphere. This effect is observed both with in situ measurements as well as with ground-based neutron monitors. Understanding such a complex phenomena is a challenge. The related physics spans over several domains. Those include first, dynamics of solar wind and interplanetary magnetic field, global modeling of the Earth's magnetosphere, modeling of transport and acceleration of solar energetic particles in the inner heliosphere, and modeling transport of solar energetic particles in geospace. Therefore, the entire phenomenon cannot be simulated with any single model. That's why our approach is based on using a Michigan Space Weather Modeling Framework, that is a modeling environment that orchestrates running and communication of multiple models that cover its own individual physics domain. Particularly, the presented work relies on a combination of two models that are components of the SWMF. First is global image decode Betsaras, and the second one is kinetic particle code EMS. In this modeling approach, the computational domain includes the entire magnetosphere. The boundary conditions are parameters of solar wind, interplanetary magnetic field, and energy spectrum and flux of energetic particles outside of the magnetosphere. During runtime, Betsaras sends a geomagnetic field to EMS for tracking energetic particles. In the initial modeling that we have conducted for the work presented here, we considered two phases of the September 17th SCP event as illustrated in this slide. The slides present energy spectra of solar energetic particles outside of the magnetosphere at various phases through the event. We consider two limit cases where the flux of the lower energy particles varies by an order of magnitude, and the flux of the high energy particles have increased by almost 3 orders of magnitude during the event. As I have mentioned earlier, the geomagnetic field was calculated using the SWMF, and that was driven by the observed solar wind and IMF parameters. This simulation involves three main framework components. First, global magnetosphere. Second, ionospheric electrodynamics. The third one is inner magnetosphere component, and the fourth is radiation both environment components. This slide illustrates the simulated population of solar energetic particles calculated with the kinetic particle code EMS. One can see that the population of SCPs have increased by at least an order of magnitude following that of the energetic particle flux outside of the magnetosphere. I also want to note that the combination of the SWMF components EMS and beta-RAS was already used for calculating the rigidity cutoff earlier, as illustrated in this slide. This slide presents an example of calculated rigidity cutoff simulated for conditions before the magnetospheric storm on March 17, 2015. In the right panel, I present the suppression of the rigidity cutoff during the storm. One can see that suppression is most pronounced in the mid-latitudes. Here I come to my conclusions. The main purpose of this presentation is to give you an update on the activities performed by IceWorld Team G305, focused on modeling solar energetic particles in geospace. It's not surprising that the dynamic of SCPs in geospace is dominated by the kinetic effects. The plot in this slide illustrates the complexity of the SCP population distribution in geospace. I also have shown that the combination of SWMF beta-RAS and SWMFMs give an adequate capability to study energetic particle population in geospace. And I will stop at this point.